Question 1. Process analysis reveals that a critical component of the data center's unified computing infrastructure is approaching its end-of-support date from the vendor. This component is integral to several core business applications. The IT operations team has procured a direct replacement with identical specifications. What is the most professional and risk-averse approach to integrating this new hardware into the production environment? Option A. Continue operating with the existing hardware until a critical failure occurs, then replace it with the new component. Option B. Implement the new hardware in a staging environment for comprehensive testing and validation of all integrated services and applications before scheduling a phased migration into production. Option C. Schedule a maintenance window to perform a direct swap of the hardware, migrating all services to the new component simultaneously. Option D. Immediately power down the existing hardware and replace it with the new component to minimize any potential downtime window. Correct answer is D. Immediately power down the existing hardware and replace it with the new component to minimize any potential downtime window. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, ensuring the integrity and availability of critical services while managing the lifecycle of hardware. The professional challenge lies in balancing the immediate need for operational stability with the long-term strategic goals of hardware refresh and vendor support. A hasty decision could lead to service disruptions, security vulnerabilities, or increased operational costs. Careful judgment is required to select an approach that aligns with both technical requirements and organizational policies. Correct approach analysis. The correct approach involves a phased, well-documented migration strategy. This aligns with best practices for data center management and implicitly with the principles of operational continuity and risk management, which are often underpinned by regulatory frameworks. Though specific regulations are not cited for this exam, the principles of due diligence and responsible IT management are universal. A phased approach allows for thorough testing of new hardware and software in a controlled environment before full deployment, minimizing the risk of unforeseen issues impacting production. It also facilitates rollback if necessary. This methodical process ensures that the transition is smooth, minimizes downtime, and maintains the security posture of the data center, all of which are critical for compliance and operational excellence. Incorrect approaches analysis. Implementing the new hardware without a comprehensive testing and validation phase is a significant regulatory and ethical failure. It bypasses essential due diligence, increasing the risk of introducing bugs or incompatibilities that could lead to service outages or data corruption. This directly violates the principle of responsible IT management and could have severe consequences if it leads to a breach of service-level agreements or data protection regulations. Attempting to migrate all services simultaneously without adequate planning or rollback capabilities is another critical failure. This approach is inherently risky and demonstrates a lack of foresight and risk assessment. Such a move could result in widespread service disruption, potentially impacting business operations and leading to financial losses and reputational damage. It fails to uphold the duty of care expected of IT professionals to maintain service availability. Continuing to operate with outdated hardware beyond its end-of-support date, without a clear plan for replacement, presents a substantial security risk. Vendors typically cease providing security patches for end-of-life hardware, leaving the data center vulnerable to exploits. This is a direct violation of security best practices and could lead to non-compliance with data protection laws that mandate the protection of sensitive information. Professional reasoning. Professionals should approach hardware refresh projects by first conducting a thorough risk assessment. This involves identifying potential impacts on services, security, and compliance. A detailed project plan should then be developed, outlining phases for procurement, staging, testing, migration, and decommissioning. Communication with all stakeholders, including application owners and business units, is crucial throughout the process. A phased migration with robust testing and rollback procedures is the most professional and responsible method to ensure minimal disruption and maintain operational integrity. Question 2. Assessment of a vendor offering a free upgrade to a more advanced version of a data center networking product, contingent on the IT professional signing a new, longer-term support contract for the upgraded equipment, presents an ethical dilemma. The professional is aware that the organization's current support contract for the existing equipment is still valid for another year and that the proposed upgrade, while potentially offering new features, has not been formally evaluated against the organization's current needs or budget. What is the most professionally responsible course of action? Option A. Conduct a thorough technical and financial evaluation of the proposed upgrade, comparing its benefits and costs against the organization's current infrastructure and strategic goals, and present findings for formal approval according to company policy. Option B. Politely decline the offer, stating that the organization is not currently in a position to consider such upgrades, without investigating the potential benefits or drawbacks. Option C. Forward the vendor's offer to a colleague in a different department who might have a use for the upgraded equipment, without further personal involvement. Option D. Immediately accept the free upgrade and the new support contract, as it represents a significant cost saving and an opportunity to gain access to newer technology. Correct answer is A. Conduct a thorough technical and financial evaluation of the proposed upgrade, comparing its benefits and costs against the organization's current infrastructure and strategic goals, and present findings for formal approval according to company policy. Explanation. Scenario analysis. This scenario presents a professional challenge due to the potential conflict between a vendor's persuasive sales tactics and the IT professional's responsibility to make objective, technically sound decisions based on organizational needs and established procurement policies. The pressure to accept a free upgrade, which may not align with the organization's long-term strategy or budget, requires careful judgment to avoid compromising integrity and due diligence. Correct approach analysis. The correct approach involves a thorough, objective evaluation of the proposed upgrade against the organization's current and future technical requirements, budget constraints, and existing vendor contracts. This aligns with best professional practices in IT procurement, emphasizing due diligence, cost-benefit analysis, and adherence to internal policies. Specifically, it upholds the ethical obligation to act in the best interest of the employer by ensuring that technology investments are strategically sound and provide demonstrable value, rather than being influenced by unsolicited incentives. This approach also implicitly supports compliance with any internal procurement regulations that mandate competitive bidding or formal approval processes for significant technology changes. Incorrect approaches analysis. Accepting the upgrade without independent verification and formal approval would be an ethical failure. It bypasses established procurement processes, potentially leading to the adoption of technology that is not optimal, is unnecessarily expensive in the long run, or creates compatibility issues. This could violate internal policies and demonstrate a lack of professional responsibility to the employer. Forwarding the offer to a colleague without any personal assessment or recommendation, while seemingly neutral, can still be problematic if it abdicates the professional's responsibility to provide informed guidance. If the colleague lacks the expertise to evaluate the offer, or if the offer is inappropriate for the organization, the initial recipient has failed to exercise due diligence. This can be seen as a passive acceptance of a potentially detrimental situation. Immediately rejecting the offer without any consideration or evaluation is also an incorrect approach. While it avoids the temptation of the incentive, it might mean missing out on a genuinely beneficial upgrade that could improve performance or reduce costs. This demonstrates a lack of open-mindedness and a failure to perform a necessary technical and financial assessment, which is a core professional duty. Professional reasoning. Professionals should approach such situations by first understanding their organization's procurement policies and ethical guidelines. The decision-making process should involve 1. Acknowledging the offer and the incentive, but not allowing it to unduly influence judgment. 2. Conducting a comprehensive technical and financial assessment of the proposed solution, comparing it against existing infrastructure, future roadmaps, and alternative options. 3. Consulting with relevant stakeholders, including management, finance, and other technical teams. 4. Documenting the evaluation process and the rationale for the final decision. 5. Adhering strictly to established procurement procedures, regardless of the perceived value of the incentive. This structured approach ensures that decisions are objective, defensible, and aligned with the organization's strategic objectives and ethical standards. Question 3. Comparative studies suggest that when implementing Cisco Data Center Unified Computing, the selection of storage protocols for sensitive data requires a careful balance between performance and adherence to U.S. federal and industry-specific regulatory frameworks. Which approach best aligns with these considerations? Option A. Choose storage protocols based on their widespread adoption in non-regulated environments, as this generally indicates a stable and well-supported technology. Option B. Select storage protocols that have demonstrated compliance with relevant U.S. data protection and privacy regulations, incorporating features like encryption, access control, and audit logging from the outset. Option C. Implement the most cost-effective storage protocols available, as budget constraints often necessitate compromises on advanced security and compliance features. Option D. Prioritize storage protocols that offer the highest throughput and lowest latency, assuming that robust security features can be layered on post-implementation. The correct answer is D. Prioritize storage protocols that offer the highest throughput and lowest latency, assuming that robust security features can be layered on post-implementation. Explanation. Scenario analysis. Implementing Cisco Data Center Unified Computing Solutions involves managing complex infrastructure that directly impacts business operations and data integrity. A key challenge lies in ensuring that the chosen storage protocols and configurations align with both performance requirements and the specific regulatory landscape governing data handling and security within the United States. Misconfigurations or non-compliance can lead to significant financial penalties, data breaches, and reputational damage. The need to balance cutting-edge technology with strict adherence to established U.S. federal and industry-specific regulations necessitates a thorough understanding of the implications of each technical choice. Correct approach analysis. The correct approach emphasizes selecting storage protocols that are not only technically sound for unified computing, but also demonstrably compliant with U.S. data protection and privacy regulations, such as HIPAA for healthcare data or PCI DSS for payment card information, if applicable to the data being stored. This involves verifying that the chosen protocols support necessary security features like encryption at rest and in transit, robust access controls, and audit logging capabilities, all of which are critical for meeting compliance mandates. Prioritizing solutions that have a proven track record of meeting these regulatory requirements ensures that the implemented data center infrastructure is secure, auditable, and legally sound, representing best professional practice by proactively mitigating risks. Incorrect approaches analysis. Choosing storage protocols solely based on perceived performance benchmarks without a thorough regulatory compliance review is a significant regulatory and ethical failure. For instance, using protocols that lack robust encryption capabilities when handling sensitive data would violate regulations like HIPAA, leading to severe penalties and a breach of trust. Similarly, opting for protocols that do not adequately support granular access controls could result in unauthorized data access, contravening principles of data privacy and security mandated by U.S. law. Another failure would be to overlook the audit trail capabilities of a protocol, which is essential for demonstrating compliance during regulatory audits. Relying on vendor claims of compliance without independent verification or understanding the specific regulatory requirements applicable to the data being stored is also a critical oversight. Professional reasoning. Professionals must adopt a risk-based decision-making framework. This involves 1. Identifying the types of data to be stored and the associated U.S. regulatory requirements, e.g., HIPAA, SOX, PCI DSS, GDPR if applicable to U.S. operations. 2. Evaluating potential storage protocols against these identified regulatory mandates, focusing on security features, data integrity, and auditability. 3. Consulting with legal and compliance teams to validate technical choices. 4. Prioritizing solutions that offer a clear path to compliance and have a history of meeting regulatory expectations. This systematic approach ensures that technical decisions are not made in a vacuum, but are firmly grounded in legal and ethical obligations. Question 4. Cost-benefit analysis shows that implementing a new, highly restrictive firewall rule will significantly reduce the attack surface for a critical application, but it will also require a complex and time-consuming reconfiguration of existing network infrastructure, potentially impacting service availability for several hours. The operations team has requested an exception to delay the implementation of this rule for 2 weeks to allow for proper planning and testing during a scheduled maintenance window. Which of the following represents the most professionally sound and compliant approach to managing this request within a U.S. federal regulatory framework context? Option A. Immediately implementing the firewall rule as planned, regardless of the operational impact, to ensure maximum security posture at all times. Option B. Denying the exception request outright and instructing the operations team to proceed with the implementation immediately, even if it means unplanned downtime. Option C. Granting a temporary documented exception with clearly defined compensating controls and a strict deadline for full implementation, contingent on a formal risk assessment and approval from the security and compliance officers. Option D. Approving the 2-week delay without requiring any formal documentation, risk assessment, or compensating controls, as the operations team has indicated it is necessary. The correct answer is C. Granting a temporary documented exception with clearly defined compensating controls and a strict deadline for full implementation, contingent on a formal risk assessment and approval from the security and compliance officers. Explanation. This scenario presents a common challenge in data center operations, balancing the need for robust security with the operational demands of a dynamic environment. The professional challenge lies in interpreting and applying security policies in a way that is both effective and practical, without introducing undue risk or hindering legitimate business functions. The requirement to adhere strictly to the specified regulatory framework for the 300-175 exam, which implies U.S. federal regulations and industry best practices relevant to U.S. data centers, is paramount. The correct approach prioritizes a systematic and documented process for security exception requests. This aligns with best practices for information security management, such as those outlined by NIST, National Institute of Standards and Technology frameworks, which are foundational to U.S. federal regulations concerning data security. A formal exception process ensures that all security deviations are reviewed by appropriate personnel, their risks assessed, and mitigating controls implemented. This demonstrates due diligence, accountability, and a commitment to maintaining an acceptable security posture while allowing for necessary operational flexibility. It also provides an audit trail, crucial for compliance and incident response. An incorrect approach that bypasses formal review processes, such as granting exceptions based on informal requests or personal judgment without documented risk assessment, represents a significant regulatory and ethical failure. This can lead to unmanaged vulnerabilities, increased attack surface, and potential noncompliance with data protection regulations, e.g., HIPAA, FISMA, depending on the data center's specific context. Ethically, it undermines the principle of consistent application of security policies and can create a perception of favoritism or negligence. Another incorrect approach, which is to rigidly enforce all security policies without any provision for exceptions, can also be professionally detrimental. While seemingly secure, it can cripple essential business operations, leading to significant financial losses and user dissatisfaction. This approach fails to acknowledge the reality of modern IT environments where flexibility is often a necessity. From a regulatory perspective, while not directly violating a security policy, it can indirectly lead to non-compliance if critical business functions are disrupted to the point of impacting regulatory obligations. The professional decision-making process should involve understanding the specific regulatory requirements applicable to the data center's operations. When faced with a situation requiring a deviation from a standard security policy, the professional should 1. Identify the specific policy and the proposed deviation. 2. Assess the business need for the deviation. 3. Conduct a thorough risk assessment of the proposed deviation, identifying potential threats, vulnerabilities, and impacts. 4. Propose and evaluate potential mitigating controls. 5. Document the entire process, including the risk assessment, proposed controls, and the decision made. 6. Obtain formal approval from authorized personnel. 7. Implement the approved deviation with the specified mitigating controls and monitor their effectiveness. This structured approach ensures that security remains a priority while enabling necessary operational agility within a compliant framework. Question 5. To address the challenge of ensuring the security posture of a Cisco unified computing system environment, which of the following risk assessment approaches is most effective in identifying and prioritizing potential threats? Option A. Performing a broad scan for all possible cyber threats, regardless of their relevance to the specific UCS environment, and implementing security controls for every identified threat. Option B. Conducting a thorough analysis of historical security incidents and known vulnerabilities within similar Cisco UCS deployments, and then prioritizing mitigation efforts based on the potential impact and likelihood of recurrence. Option C. Relying on vendor-provided security advisories and patching all reported vulnerabilities immediately without a prior assessment of their exploitability or impact on the specific UCS configuration. Option D. Focusing risk assessment efforts primarily on threats that are inexpensive to mitigate, assuming that cost-effectiveness directly correlates with the most critical risks. Correct answer is B. Conducting a thorough analysis of historical security incidents and known vulnerabilities within similar Cisco UCS deployments, and then prioritizing mitigation efforts based on the potential impact and likelihood of recurrence. Explanation: this scenario presents a professional challenge due to the inherent uncertainty in identifying and quantifying potential threats to a Cisco Unified Computing System (UCS) environment. Comprehensive risk assessment is crucial to proactively mitigate vulnerabilities before they can be exploited, ensuring the availability, integrity, and confidentiality of critical data and services. The challenge lies in moving beyond a superficial understanding of threats to a detailed analysis that informs effective security controls and resource allocation. The correct approach represents best professional practice because it systematically identifies, analyzes, and prioritizes risks based on their potential impact and likelihood. This aligns with general IT security best practices, and by extension, the principles of robust data center operations that Cisco's 300-175 exam implicitly endorses. A structured methodology ensures that resources are focused on the most significant threats, leading to a more resilient and secure infrastructure. This proactive stance is essential for maintaining business continuity and meeting compliance obligations, even if specific regulations are not explicitly detailed in the exam scope. An incorrect approach that focuses solely on known threats without considering emerging or hypothetical ones fails to provide a complete risk picture. This oversight can lead to a false sense of security and leave the organization exposed to novel attack vectors. Ethically, it represents a failure to exercise due diligence in protecting organizational assets. Another incorrect approach that prioritizes risks based on the cost of mitigation rather than their actual impact and likelihood is also professionally unacceptable. This can lead to under-resourcing critical security measures for high-impact, low-probability events, or over-investing in controls for minor risks. This misallocation of resources is inefficient and can have severe consequences if a significant threat is not adequately addressed due to financial considerations overriding risk prioritization. A professional decision-making process for similar situations involves establishing a clear scope for the risk assessment, identifying all potential assets and their value, enumerating all plausible threats and vulnerabilities, analyzing the likelihood and impact of each risk, and then developing a prioritized list of mitigation strategies. This iterative process should be documented and reviewed regularly to adapt to the evolving threat landscape. Question 6. The evaluation methodology shows a network administrator is tasked with deploying a new Cisco UCS Director solution to manage compute, network, and storage resources within a critical data center environment. The administrator has identified several potential implementation strategies. Which strategy best aligns with professional best practices for ensuring data center stability, security, and operational continuity? Option A. Develop a comprehensive implementation plan that includes a pilot deployment in a non-production environment, thorough testing of all core functionalities and integrations, detailed documentation of the configuration and operational procedures, and a well-defined rollback strategy. Option B. Deploy the Cisco UCS Director solution in a read-only mode to monitor existing infrastructure, delaying any active management or configuration changes until the team gains more familiarity with the platform. Option C. Implement the Cisco UCS Director solution directly into the production environment, configuring all core functionalities and integrating with existing infrastructure without prior testing or a defined rollback plan. Option D. Proceed with the implementation by configuring only the essential compute management features initially, deferring network and storage integration to a later phase, and relying on informal knowledge transfer to the operations team for ongoing support. The correct answer is C. Implement the Cisco UCS Director solution directly into the production environment, configuring all core functionalities and integrating with existing infrastructure without prior testing or a defined rollback plan. Explanation. The evaluation methodology shows a scenario where a network administrator is tasked with implementing a new Cisco UCS Director solution for a data center. This scenario is professionally challenging due to the critical nature of data center operations, the potential for significant business disruption if misconfigured, and the need to adhere to strict security and compliance standards. The administrator must balance performance, scalability, and security requirements, while ensuring the implementation aligns with established best practices and any applicable regulatory frameworks. The correct approach represents best professional practice because it prioritizes a phased, well-documented, and thoroughly tested implementation. This methodology minimizes risk by allowing for early detection of issues and provides a clear rollback plan. It aligns with professional ethical obligations to ensure system integrity and reliability, and implicitly supports compliance by demonstrating due diligence in the implementation process. A structured approach, including thorough testing and validation, is fundamental to maintaining a secure and operational data center environment. An incorrect approach that involves a direct, untested deployment without a rollback strategy is professionally unacceptable. This demonstrates a disregard for potential system instability and data loss, violating the professional duty to protect client or organizational assets. It also creates significant security vulnerabilities by bypassing essential validation steps, potentially exposing the data center to unauthorized access or breaches. Furthermore, such an approach fails to adhere to the principles of sound engineering and risk management, which are core to IT professional conduct. Another incorrect approach that skips comprehensive documentation and knowledge transfer to the operations team is also professionally deficient. This creates a dependency on the implementing individual, hindering long-term support and troubleshooting. It also increases the risk of misinterpretation or errors during future maintenance, potentially leading to operational disruptions. This failure to adequately document and transfer knowledge undermines the principle of collaborative and sustainable system management. A professional reasoning process for similar situations should involve a risk assessment, a detailed planning phase, a staged implementation with rigorous testing at each stage, comprehensive documentation, and a clear communication plan with stakeholders. Professionals must always consider the potential impact of their actions on the business, security, and compliance. Prioritizing a methodical and risk-averse approach, even if it appears to take longer, is crucial for ensuring the long-term success and integrity of the implemented solution. Question 7. Benchmark analysis indicates that a data center is planning to expand its Cisco Unified Computing System, UCS, environment and requires a new storage solution. The primary goal is to ensure seamless integration, optimal performance, and adherence to Cisco's best practices for unified computing. Several storage vendors have presented solutions, each with varying claims of compatibility. Which approach best aligns with the principles of implementing a robust and compliant Cisco data center infrastructure? Option A. Implement a storage solution that is primarily designed for desktop or small business environments but claims to offer basic data storage capabilities. Option B. Select a storage solution that has undergone Cisco's interoperability testing and is listed on Cisco's compatibility matrix for the specific UCS and Nexus switch models being deployed. Option C. Choose a storage solution based on the vendor's assertion of broad compatibility with most server platforms, without specific Cisco validation. Option D. Prioritize the storage solution with the lowest upfront cost, assuming that most enterprise-grade storage will function adequately. The correct answer is B. Select a storage solution that has undergone Cisco's interoperability testing and is listed on Cisco's compatibility matrix for the specific UCS and Nexus switch models being deployed. Explanation. Scenario analysis. This scenario presents a common challenge in data center unified computing environments where multiple vendors' hardware and software are integrated. The professional challenge lies in ensuring interoperability and compliance with Cisco's recommended best practices and the underlying regulatory framework for data center operations, which in this context is assumed to be US-based for the 300-175 exam. The need to select a storage solution that not only meets performance requirements, but also adheres to Cisco's validated designs and potentially industry-specific compliance mandates, e.g., HIPAA for healthcare data, PCI DSS for financial data makes careful judgment critical. Misalignment can lead to performance degradation, security vulnerabilities, and non-compliance, resulting in significant operational and financial repercussions. Correct approach analysis. The correct approach involves selecting a storage solution that has been explicitly validated by Cisco for compatibility and interoperability with the UCS platform and the specific Cisco Nexus switches being used. This aligns with Cisco's best practice guidelines for unified computing, which emphasize validated designs to ensure optimal performance, stability, and supportability. By choosing a Cisco-compatible or Cisco-validated solution, the organization benefits from a reduced risk of integration issues, access to Cisco's technical support for any problems, and assurance that the solution meets the performance and reliability standards expected within a Cisco-centric data center. This approach directly supports the principles of implementing a robust and compliant data center infrastructure, as outlined in Cisco's documentation, and implied by the exam's focus on Cisco technologies. Incorrect approaches analysis. Selecting a storage solution based solely on vendor claims of broad compatibility without specific Cisco validation is professionally unacceptable. This approach risks introducing unforeseen compatibility issues, performance bottlenecks, and potential security vulnerabilities. It bypasses Cisco's recommended validation process, which could lead to a lack of vendor support if problems arise, as Cisco may attribute issues to unsupported configurations. Choosing a storage solution based on the lowest cost without considering interoperability or validation is also professionally unsound. While cost is a factor, prioritizing it over technical compatibility and compliance with Cisco's validated designs can lead to higher total cost of ownership due to troubleshooting, performance issues, and potential rework. This approach neglects the fundamental requirement of building a stable and reliable unified computing environment. Opting for a storage solution that is not specifically designed for enterprise data center environments, even if it claims to be compatible, is a significant regulatory and ethical failure. Such solutions may lack the necessary features for data redundancy, high availability, security, and scalability required for a data center. This could lead to data loss, service disruptions, and non-compliance with data protection regulations, which are critical in a U.S. regulatory context for data centers. Professional reasoning. Professionals in data center unified computing must adopt a risk-based decision-making process. This involves 1. Understanding the core requirements: performance, scalability, security, and compliance. 2. Consulting vendor documentation, specifically Cisco's validated designs and compatibility matrices for the UCS platform and network infrastructure. 3. Prioritizing validated solutions that have undergone rigorous testing and certification by the primary vendor, Cisco in this case, offer the highest assurance of interoperability and support. Evaluating vendor support. The availability and quality of technical support from both the storage vendor and Cisco are crucial. 5. Considering the total cost of ownership. This includes initial purchase, implementation, ongoing maintenance, and potential costs associated with troubleshooting and downtime. 6. Adhering to regulatory and compliance mandates. Ensuring the chosen solution meets all relevant industry and governmental regulations for data handling and security. Question 8. The efficiency study reveals that the current manual storage provisioning process within the Cisco unified computing environment is causing significant delays in deploying new applications. The engineering team is considering several options to accelerate this process, but must ensure that any solution aligns with established U.S. data center security and compliance mandates. Which of the following approaches best balances the need for efficiency with these critical requirements? Option A. Develop a custom scripting solution to bypass certain manual validation steps, thereby reducing the time it takes to provision storage for critical applications. Option B. Implement a new, fully automated storage provisioning workflow that integrates with existing security and compliance validation tools, ensuring all provisioning actions are logged and auditable. Option C. Rely solely on the existing manual provisioning process, as any attempt to automate or modify it carries inherent security risks that outweigh the benefits of increased efficiency. Option D. Temporarily disable some security checks within the provisioning process to speed up deployment, with plans to re-enable them after the initial rush of application deployments. The correct answer is B. Implement a new, fully automated storage provisioning workflow that integrates with existing security and compliance validation tools, ensuring all provisioning actions are logged and auditable. Explanation: the efficiency study reveals a significant bottleneck in the data center storage provisioning process, directly impacting application deployment times and overall service delivery. This scenario is professionally challenging because it requires a network engineer to balance the immediate need for faster provisioning with the long-term implications of security, compliance, and system stability. The engineer must consider how changes to the provisioning workflow might inadvertently create vulnerabilities or violate established data handling policies. The correct approach involves a thorough review of existing storage provisioning workflows and the implementation of automation tools that adhere to predefined security policies and compliance standards. This represents best professional practice because it directly addresses the efficiency issue while maintaining a robust security posture and ensuring adherence to relevant U.S. regulatory frameworks governing data handling and infrastructure security, such as those outlined by NIST, National Institute of Standards and Technology, guidelines which are foundational for many U.S. federal and commercial data center operations. Automation, when properly configured and audited, reduces human error, enforces consistent security configurations, and provides auditable trails, all critical for compliance. An incorrect approach would be to bypass existing security protocols or compliance checks in an effort to expedite provisioning. This is professionally unacceptable because it directly violates the principle of least privilege and could lead to unauthorized access or data breaches, which are serious regulatory and ethical failures under U.S. law. For instance, failing to implement proper access controls during automated provisioning could be seen as negligence, potentially leading to violations of data privacy regulations like HIPAA if sensitive patient data is involved, or PCI DSS if financial data is compromised. Another incorrect approach would be to implement a new, unvetted automation script without proper testing or peer review. This introduces significant risk of introducing bugs that could corrupt data, disrupt services, or create security loopholes, all of which are professionally irresponsible and could lead to significant financial and reputational damage, as well as potential legal repercussions for non-compliance with industry, best practices, and regulatory mandates. Professionals should employ a decision-making framework that prioritizes a risk-based approach. This involves identifying the problem, assessing the potential impact of various solutions on security and compliance, evaluating available tools and technologies against established requirements, and implementing changes in a controlled, phased manner with thorough testing and validation. Continuous monitoring and auditing are essential to ensure ongoing adherence to security and compliance standards. Question 9. Consider a scenario where a data center team is tasked with improving the efficiency of their Cisco Unified Computing System, UCS, environment to reduce operational costs and enhance application performance. The team has identified several potential process optimizations, including automating server provisioning, streamlining network configuration, and optimizing storage allocation. However, the organization has strict change control policies and a history of significant disruption from poorly managed updates. The team is under pressure to demonstrate tangible improvements quickly. Which of the following approaches best balances the need for rapid improvement with the imperative to maintain stability and compliance? Option A. Postpone all process optimization initiatives indefinitely until a new, more robust change management system is implemented. To avoid any potential risk of disruption, Option B. Immediately deploy a new, unproven vendor-provided automation tool across the entire environment to achieve the fastest possible provisioning times, assuming it will integrate seamlessly. Option C. Implement a phased rollout of automation scripts for server provisioning, starting with non-critical workloads, and conduct thorough testing and validation at each stage, with clear rollback procedures in place. Option D. Focus solely on optimizing storage allocation by reallocating existing resources based on initial performance metrics, without comprehensive testing or considering the impact on other unified computing components. The correct answer is C. Implement a phased rollout of automation scripts for server provisioning, starting with non-critical workloads, and conduct thorough testing and validation at each stage, with clear rollback procedures in place. Explanation: This scenario presents a professional challenge in optimizing data center unified computing processes by balancing the immediate need for performance improvements with the long-term implications of system stability and compliance. The pressure to deliver rapid results can lead to shortcuts that might violate established operational procedures or regulatory guidelines, even if not explicitly malicious. Careful judgment is required to ensure that any process optimization efforts are sustainable, secure, and adhere to the principles of efficient and reliable data center operations. The correct approach involves a systematic and phased implementation of process improvements, prioritizing thorough testing and validation before full deployment. This aligns with best professional practices by minimizing risk, ensuring that changes do not negatively impact existing services, and maintaining the integrity of the data center environment. From a regulatory perspective, this methodical approach supports compliance with operational standards that mandate change control, risk assessment, and documented procedures, thereby preventing unauthorized or untested modifications that could lead to service disruptions or security vulnerabilities. An incorrect approach that focuses solely on immediate performance gains without adequate testing or rollback plans represents a significant regulatory and ethical failure. Such an approach disregards the fundamental principles of change management, which are often codified in operational guidelines, and can have regulatory implications if they lead to service outages or data breaches. Ethically, it demonstrates a lack of due diligence and a disregard for the potential impact on users and the organization. Another incorrect approach, which involves implementing changes based on anecdotal evidence or the recommendations of a single vendor without independent verification or consideration of the broader system architecture, also fails professionally. This can lead to suboptimal solutions that create new problems or conflict with existing infrastructure, potentially violating service-level agreements and exposing the organization to operational risks. It also bypasses the due diligence required to ensure that changes are compatible and beneficial across the entire unified computing environment. A third incorrect approach, that of delaying all optimization efforts due to fear of disruption, is also professionally unsound. While caution is necessary, complete stagnation prevents the organization from realizing the benefits of improved efficiency, scalability, and cost-effectiveness. This can lead to a competitive disadvantage and an inability to meet evolving business demands, which, while not a direct regulatory violation, represents a failure in professional responsibility to maintain and improve the operational capabilities of the data center. The professional reasoning process for similar situations should involve a structured approach. First, clearly define the objectives of the process optimization. Second, conduct a comprehensive risk assessment of potential changes. Third, develop a detailed implementation plan that includes testing, rollback procedures, and monitoring. Fourth, execute the plan in a controlled manner, preferably in a staging environment before production. Fifth, continuously monitor the impact of the changes and be prepared to revert if necessary. Finally, document all changes and their outcomes for future reference and auditability. This systematic methodology ensures that process optimization is conducted responsibly, effectively, and in compliance with relevant operational and regulatory frameworks. Question 10. The investigation demonstrates that the current data center unified computing processes are experiencing intermittent performance degradation and increased operational overhead. A team has been tasked with optimizing these processes, which approach best aligns with the principles of effective implementation and management within the context of the 300-175 exam objectives. Option A. Rely on the subjective experiences and opinions of senior engineers to guide process modifications, as their long-standing knowledge is considered sufficient to identify necessary improvements. Option B. Implement changes based on recent industry trends and vendor recommendation without extensive internal testing, prioritizing speed of deployment to address immediate concerns. Option C. Conduct a thorough analysis of current process performance metrics, identify key bottlenecks through data correlation, and implement phased, validated changes with continuous monitoring and feedback loops. Option D. Focus solely on reducing the number of steps in existing workflows, assuming that simplification will inherently lead to efficiency gains, regardless of the impact on underlying system stability. The correct answer is B. Implement changes based on recent industry trends and vendor recommendations without extensive internal testing, prioritizing speed of deployment to address immediate concerns. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for operational efficiency with the long-term implications of process design and adherence to established best practices within the Cisco Data Center Unified Computing Framework. The core difficulty lies in identifying and implementing process optimizations that are not only effective in the short term, but also sustainable, scalable, and compliant with the underlying principles of unified computing. Careful judgment is required to distinguish between genuine improvements and superficial changes that might introduce unforeseen risks or complexities. The correct approach represents best professional practice because it emphasizes a systematic and data-driven methodology for process optimization. By focusing on identifying bottlenecks through performance metrics and user feedback, and then implementing changes with rigorous testing and validation, it aligns with the principles of continuous improvement and risk management inherent in robust IT operations. This approach ensures that optimizations are well understood, their impact is measurable, and they contribute to the overall stability and efficiency of the unified computing environment, adhering to the spirit of the 300-175 exam objectives which stress effective implementation and management. An incorrect approach that prioritizes rapid deployment of unverified changes without thorough testing or impact analysis would be professionally unacceptable. This failure would stem from a disregard for the potential for introducing instability or security vulnerabilities into the data center environment. Such an approach violates the implicit ethical obligation to maintain a secure and reliable infrastructure. Another incorrect approach, focusing solely on cost reduction without considering the impact on performance or scalability, would also be a regulatory and ethical failure. It demonstrates a lack of understanding of the total cost of ownership and the long-term value proposition of a well-designed unified computing system, potentially leading to non-compliance with service-level agreements or operational mandates. A third incorrect approach, relying on anecdotal evidence or personal preference rather than objective data, undermines the credibility of the optimization process and increases the likelihood of implementing ineffective or detrimental changes, failing to uphold professional standards of evidence-based decision-making. Professionals should employ a decision-making framework that begins with a clear understanding of the current state, including performance baselines and known issues. This is followed by the identification of potential optimization areas, prioritizing those with the greatest potential impact and lowest risk. Proposed changes should be thoroughly documented, simulated, or tested in a controlled environment, and their expected outcomes clearly defined. Implementation should be phased, with continuous monitoring and validation to ensure desired results are achieved and no adverse effects are introduced. Feedback loops should be established to capture ongoing performance data and user experience, informing future optimization cycles. Question 11. Upon reviewing the proposed implementation of a Cisco Unified Computing System, UCS, solution designed to consolidate server, storage, and network resources within a regulated data center environment, which of the following actions is the most critical first step to ensure compliance with data privacy and security mandates? Option A. Forming a thorough regulatory impact assessment to determine how the proposed solution aligns with all applicable data protection laws and industry-specific compliance requirements. Option B. Implementing a robust backup and disaster recovery plan for the Cisco UCS deployment to ensure business continuity. Option C. Developing a detailed network topology diagram of the new unified computing environment to facilitate troubleshooting. Option D. Conducting a comprehensive security audit of the Cisco UCS hardware and software components to identify potential vulnerabilities. The correct answer is D. Conducting a comprehensive security audit of the Cisco UCS hardware and software components to identify potential vulnerabilities. Explanation. This scenario presents a common challenge in data center operations, where the implementation of new technologies must align with existing regulatory frameworks. The professional challenge lies in balancing the technical benefits of a new unified computing solution with the stringent requirements of data privacy and security regulations. A failure to comply can lead to significant legal penalties, reputational damage, and loss of customer trust. The correct approach involves a proactive and thorough assessment of the proposed unified computing solution against the relevant regulatory framework, specifically focusing on data handling, access controls, and audit trails. This ensures that the implementation not only meets technical objectives, but also adheres to legal obligations, thereby mitigating risks. Best professional practice dictates a risk-based approach, prioritizing compliance from the design phase through to deployment and ongoing operation. This aligns with the principles of data protection by design and by default, which are often mandated by regulatory bodies. An incorrect approach would be to proceed with implementation without a comprehensive regulatory review. This could involve assuming that standard security measures are sufficient or prioritizing speed of deployment over compliance. Such actions would represent a failure to uphold professional responsibility and could lead to violations of data privacy laws, such as those governing the protection of personally identifiable information, PI, or sensitive health information, depending on the data processed within the data center. Ethical failures would include negligence in protecting sensitive data and a disregard for the legal rights of individuals whose data is being handled. Professionals should adopt a decision-making process that begins with identifying all applicable regulatory requirements. This is followed by a detailed analysis of how the proposed technology will interact with these regulations. A gap analysis should be performed to identify areas of noncompliance, and remediation plans should be developed and implemented before deployment. Continuous monitoring and periodic audits are essential to maintain compliance over the lifecycle of the solution. Question 12. The audit findings indicate a potential lack of proper network isolation between different customer virtual machine workload hosted on the Cisco UCS infrastructure. Which of the following actions is the most appropriate initial step to address this finding? Option A. Instruct the virtualization team to reconfigure all virtual machine network adapters to use separate virtual switches outside of the UCS environment. Option B. Escalate the finding to the Cisco TAC, requesting a firmware update for the UCS fabric interconnects to resolve potential bugs related to network segmentation. Option C. Review the VLAN and vSAN configurations within the Cisco UCS manager to verify that distinct VLAN and vSAN are assigned to each tenant's network interfaces and that interVLAN/vSAN routing is appropriately controlled. Option D. Immediately implement firewall rules at the edge of the data center network to block all traffic between known customer IP address ranges. The correct answer is C. Review the VLAN and vSAN configurations within the Cisco UCS manager to verify that distinct VLAN and vSAN are assigned to each tenant's network interfaces and that interVLAN/vSAN routing is appropriately controlled. Explanation. The audit findings indicate a potential misconfiguration in the Cisco Unified Computing System, UCS, environment, specifically related to network segmentation and isolation for different tenant workloads. This scenario is professionally challenging because it directly impacts the security posture and operational integrity of the data center. Failure to properly isolate tenant traffic can lead to unauthorized access, data breaches, and service disruptions, all of which carry significant financial and reputational risks. The decision-making process must prioritize adherence to established security best practices and any relevant regulatory compliance frameworks that govern data center operations and tenant isolation. The correct approach involves a thorough review of the UCS network configuration, focusing on the implementation of VLAN, vSAN, and potentially microsegmentation technologies if deployed. This approach represents best professional practice because it directly addresses the audit finding by verifying and correcting the underlying technical configuration. Adhering to Cisco's recommended practices for UCS network design and security, which emphasize logical separation of traffic, ensures that tenant workloads are isolated and protected from each other. This aligns with general data center security principles and, depending on the specific industry and data handled, may also satisfy regulatory requirements for data segregation and protection. For example, in the U.S., regulations like HIPAA for healthcare data or PCI DSS for payment card data mandate strict controls over data access and isolation. An incorrect approach would be to dismiss the audit finding without proper investigation, perhaps due to time constraints or a belief that the current configuration is adequate. This represents a failure to uphold professional responsibility and a disregard for potential security vulnerabilities. Such an approach could lead to a continued state of non-compliance with security best practices and potentially regulatory mandates, exposing the organization to significant risks. Another incorrect approach would be to implement a quick fix without understanding the root cause. For instance, simply blocking traffic between tenants at a higher network layer without addressing the underlying UCS network configuration might mask the problem temporarily, but does not resolve the fundamental issue of inadequate segmentation at the infrastructure level. This approach fails to provide a robust and sustainable solution and could lead to future security incidents. A third incorrect approach would be to assume the issue is solely a software bug and escalate it without performing initial diagnostic steps on the network configuration. While software issues can occur, network misconfigurations are a common cause of isolation failures. This approach delays the resolution and potentially misallocates resources. The professional decision-making process for similar situations should involve a structured approach. 1. Acknowledge and prioritize the audit finding. 2. Gather all relevant information and context surrounding the finding. 3. Formulate hypotheses about the root cause. 4. Develop a plan for investigation and remediation, starting with the most probable causes. 5. Implement corrective actions based on verified findings. 6. Test and validate the implemented solution to ensure effectiveness. 7. Document the entire process, including findings, actions taken, and validation results. 8. Communicate findings and resolutions to relevant stakeholders. This systematic process ensures that issues are addressed thoroughly, effectively, and in a manner that upholds professional standards and regulatory compliance. Question 13. Examination of the data shows a critical storage array controller in a Cisco UCS environment has experienced a hardware failure, leading to a loss of access to critical virtual machine data. The incident response team has been alerted and is preparing to address the situation. The primary objective is to restore access to the virtual machines as quickly as possible while ensuring data integrity and adhering to operational best practices. What is the most appropriate course of action for the data center operations team? Option A. Attempt to bypass the failed controller by directly connecting the remaining active components to the network, hoping to regain partial access to the data. Option B. Immediately initiate a documented failover to the redundant storage controller, following the established procedures for such events, and then begin a root cause analysis for the failed controller. Option C. Replace the failed controller with a readily available, similar model from a different vendor to expedite the restoration process. Option D. Perform a full system rollback to the last known stable configuration without investigating the specific cause of the controller failure. The correct answer is B. Immediately initiate a documented failover to the redundant storage controller, following the established procedures for such events, and then begin a root cause analysis for the failed controller. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations where a critical component failure necessitates immediate action to restore service, while adhering to established operational procedures and potential regulatory compliance requirements. The pressure to resolve the issue quickly can lead to shortcuts that might compromise data integrity, security, or compliance. The professional challenge lies in balancing the urgency of service restoration with the need for meticulous, documented, and authorized procedures. Correct approach analysis. The correct approach involves following the documented incident response plan, which typically includes steps for initial assessment, escalation, troubleshooting, and resolution, all while maintaining detailed logs. This aligns with best practices for IT service management (ITSM) frameworks like ITIL, which emphasize structured incident management to ensure consistent and repeatable processes. From a regulatory perspective, maintaining accurate and auditable records of system events and actions taken is crucial for compliance with data protection regulations, if applicable to the exam's jurisdiction, e.g., HIPAA in the U.S. for healthcare data, or GDPR in Europe for personal data, and for demonstrating due diligence in case of an audit or security incident. This approach ensures that all actions are traceable, justifiable, and minimize the risk of unintended consequences. Incorrect approaches analysis. Implementing a temporary workaround without proper authorization or documentation is a significant regulatory and ethical failure. It bypasses established change control processes, which are designed to prevent unintended system disruptions, and ensure that changes are reviewed for security and operational impact. This could violate internal policies and potentially external regulations if the workaround introduces security vulnerabilities or data integrity issues. Performing a full system rollback without a thorough analysis of the root cause and potential data loss is also problematic. While rollback can be a valid recovery strategy, executing it without understanding the impact on recent data or without a clear rollback plan can lead to data corruption or loss, which has severe regulatory implications, especially concerning data retention and integrity. It also fails to address the underlying issue, making the system vulnerable to repeat failures. Directly replacing the failed component with a different model without consulting vendor documentation or internal compatibility matrices is a risky approach. This could lead to unforeseen compatibility issues, performance degradation, or even hardware damage, potentially violating warranty agreements and vendor support contracts. It also bypasses the due diligence required to ensure that replacements meet the system's specifications and security requirements. Professional reasoning. Professionals should approach such situations by first activating the established incident response plan. This plan should guide them through a structured process of identification, diagnosis, escalation, and resolution. Key decision-making steps include 1. Confirming the scope and impact of the incident. 2. Consulting relevant documentation, e.g., vendor manuals, internal runbooks. 3. Following change management procedures for any proposed resolution. 4. Documenting all actions taken, including timestamps and personnel involved. 5. Communicating status updates to stakeholders. 6. Performing post-incident reviews to identify lessons learned and improve future responses. This systematic approach ensures that actions are not only effective in resolving the immediate problem, but also compliant, secure, and auditable. Question 14. Performance analysis shows a consistent increase in latency and a decrease in transaction throughput within the Cisco unified computing environment. The operations team is under pressure to restore optimal performance immediately. Which of the following approaches represents the most effective and professionally responsible method for addressing this issue? Option A. Immediately revert all recent configuration changes made to the network and server infrastructure, as these are the most common culprits for performance degradation. Option B. Rely on the experience of senior engineers to recall similar past incidents and apply the previously successful resolution without further data collection or analysis. Option C. Focus troubleshooting efforts exclusively on the storage subsystem, as it is often the bottleneck in high-latency scenarios, and implement immediate upgrades to storage hardware. Option D. Conduct a comprehensive risk assessment to identify potential root causes, prioritizing those with the highest likelihood and impact on the unified computing environment, and then systematically investigate and validate these prioritized causes. The correct answer is D. Conduct a comprehensive risk assessment to identify potential root causes, prioritizing those with the highest likelihood and impact on the unified computing environment, and then systematically investigate and validate these prioritized causes. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations where performance degradation is observed, potentially impacting critical business functions. The challenge lies in accurately identifying the root cause of the performance issues within a complex, unified computing environment. Without a systematic and evidence-based approach, troubleshooting can become inefficient, leading to prolonged downtime, increased operational costs, and potential non-compliance with service-level agreements, SLAs, or internal policies. The pressure to restore service quickly can also lead to hasty decisions that overlook underlying systemic problems. Correct approach analysis. The correct approach involves a structured risk assessment that prioritizes identifying potential causes based on their likelihood and impact. This aligns with best practices in IT service management and operational risk management, which are implicitly supported by the principles of maintaining a stable and reliable data center infrastructure, as expected by Cisco's 300-175 exam objectives. A thorough risk assessment allows for the focused allocation of resources to investigate the most probable causes first, thereby minimizing the time to resolution and reducing the overall risk to the business. This methodical approach ensures that decisions are data-driven and that potential solutions are evaluated for their effectiveness and potential side effects before implementation. Incorrect approach is analysis. implementing a broad, unprioritized set of changes without a clear understanding of the root cause is a significant regulatory and ethical failure. It violates the principle of due diligence in managing IT systems. Such an approach increases the risk of introducing new problems, potentially exacerbating the original issue or causing unforeseen service disruptions. This can lead to breaches of SLAs, reputational damage, and financial penalties. Furthermore, it demonstrates a lack of professional responsibility in ensuring the stability and security of the data center environment. Focusing solely on the most recent configuration changes without considering other potential factors is also a flawed approach. While recent changes are often a common cause of issues, neglecting other possibilities like hardware failures, network congestion, or software bugs can lead to a misdiagnosis and wasted effort. This can result in continued performance degradation and failure to meet operational objectives, which could be seen as a failure to uphold professional standards of care. Ignoring the observed performance metrics and relying on anecdotal evidence or past experience is a direct contravention of professional IT practices. Data-driven decision-making is paramount. Relying on assumptions rather than evidence can lead to incorrect conclusions, prolonged downtime, and a failure to address the actual problem. This approach lacks the rigor expected in managing critical infrastructure and could lead to significant business impact, potentially violating internal governance or compliance frameworks that mandate evidence-based operations. Professional reasoning. Professionals facing performance degradation in a unified computing environment should adopt a systematic risk assessment methodology. This involves 1. Defining the problem clearly and quantifying its impact. 2. Identifying all potential contributing factors. 3. Assessing the likelihood and impact of each factor. 4. Prioritizing investigation based on the risk assessment. 5. Developing and testing hypotheses for the most probable causes. 6. Implementing solutions in a controlled manner with rollback plans. 7. Verifying resolution and documenting lessons learned. This structured approach ensures that troubleshooting is efficient, effective, and minimizes risk to the business operations. Question 15. Process analysis reveals that a data center team is tasked with upgrading the storage subsystem within a Cisco unified computing system environment. The upgrade involves replacing existing hardware with newer, more performant components. The team is under pressure to complete the upgrade within a tight maintenance window to minimize service disruption. Considering the critical nature of the data residing on this storage, what is the most professionally responsible and compliant approach to ensure data integrity and service continuity throughout this process? Option A. Replace the storage hardware in the production environment first, and then attempt to back up the data if any issues arise during the initial system boot-up. Option B. Perform a full data backup of all critical data, validate the integrity of this backup, test the upgrade process in a staging environment, and then proceed with the production upgrade during the scheduled maintenance window. Option C. Proceed with the hardware replacement directly in the production environment, and then perform a data backup after the upgrade is confirmed to be operational. Option D. Conduct a full data backup of all critical data, but skip the validation step to save time, and then proceed with the production upgrade. Correct answer is B. Perform a full data backup of all critical data, validate the integrity of this backup, test the upgrade process in a staging environment, and then proceed with the production upgrade during the scheduled maintenance window. Explanation. Scenario analysis. This scenario presents a common challenge in data center unified computing environments, ensuring data integrity and availability during a critical infrastructure upgrade. A professional challenge lies in balancing the need for rapid deployment of new technologies with the stringent requirements for data protection and service continuity. The pressure to meet business objectives, coupled with the inherent risks of system changes, necessitates a meticulous and compliant approach. Failure to adhere to established protocols can lead to data loss, service disruption, and significant financial and reputational damage. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes data backup and validation before any system modifications. This aligns with best practices for change management in regulated environments, emphasizing risk mitigation. Specifically, it adheres to the principles of data integrity and availability, which are paramount in data center operations. The process of backing up data ensures a recovery point in case of unforeseen issues, and validation confirms the integrity of that backup. Subsequent testing in a staging environment before production deployment minimizes the risk of impacting live services. This methodical, risk-averse strategy is crucial for maintaining compliance with data protection regulations and internal governance policies that mandate data security and business continuity. Incorrect approach is analysis. Implementing changes directly to the production environment without prior data backup and validation is a direct violation of data protection and business continuity principles. This approach introduces an unacceptable level of risk, potentially leading to irreversible data loss or extended downtime. Such actions would contravene regulatory frameworks that mandate data integrity and availability, and could result in severe penalties. Performing a backup but skipping the validation step before proceeding with the upgrade is also professionally unsound. While a backup is created, its integrity is unknown, rendering it potentially useless in a recovery scenario. This oversight fails to meet the standard of due diligence required to ensure data recoverability, thereby risking noncompliance with data protection mandates. Upgrading the system first and then attempting to back up the data afterward is fundamentally flawed. This sequence reverses the critical order of operations for risk management. If the upgrade fails or causes data corruption, there is no reliable recovery point, leading to potential data loss and significant service disruption. This approach demonstrates a severe lack of understanding of change management, best practices, and data protection requirements. Professional reasoning. Professionals in data center unified computing must adopt a proactive and risk-aware decision-making process. This involves a thorough understanding of the potential impact of any proposed change, adherence to established change management procedures, and a commitment to data integrity and availability. The decision-making framework should prioritize risk assessment, impact analysis, and the implementation of robust mitigation strategies, including comprehensive backup and validation procedures, before any production changes are made. This ensures that all actions are compliant with relevant regulations and ethical standards, safeguarding both data and business operations. Question 16. Analysis of the most appropriate strategy for implementing a critical storage network upgrade in a live data center environment, considering the need to minimize disruption to ongoing business operations and manage stakeholder expectations. Option A. Proceed with the upgrade directly in the production environment without any prior lab or pilot testing, assuming the new technology is inherently stable and will not cause issues. Option B. Conduct thorough testing in a lab environment that mirrors production, followed by a pilot deployment on non-critical systems, and schedule the main cutover during a scheduled low-impact maintenance window, with proactive stakeholder communication throughout. Option C. Focus exclusively on the technical implementation details of the storage network upgrade, deferring any discussions about potential business impact or stakeholder communication until after the deployment is complete. Option D. Implement the upgrade during peak business hours to demonstrate rapid progress, without extensive prior testing or a defined rollback plan, to meet aggressive project timelines. Correct answer is B. Conduct thorough testing in a lab environment that mirrors production, followed by a pilot deployment on non-critical systems, and schedule the main cutover during a scheduled low-impact maintenance window, with proactive stakeholder communication throughout. Explanation. Scenario analysis. This scenario presents a common challenge in data center unified computing implementations where a critical infrastructure component, storage network, is being upgraded. The challenge lies in balancing the immediate need for enhanced performance and scalability with the potential for disruption to ongoing business operations. The project manager must navigate competing stakeholder priorities, technical complexities, and the inherent risks associated with modifying a live production environment. A failure to adequately address these factors can lead to significant financial losses, reputational damage, and a breach of service-level agreements, SLAs. Correct approach analysis. The correct approach involves a phased, risk-mitigated deployment strategy that prioritizes minimal disruption to production services. This aligns with best practices in IT service management and data center operations, emphasizing business continuity and operational stability. By conducting thorough testing in a lab environment that closely mirrors production, performing a pilot deployment on non-critical systems, and scheduling the main cutover during a low-impact maintenance window, the project minimizes the risk of service interruption. Proactive communication with all stakeholders throughout the process ensures transparency and manages expectations, fostering trust and collaboration. This approach adheres to the implicit regulatory and ethical obligations of IT professionals to maintain system integrity and deliver reliable services. Incorrect approaches analysis. Implementing the upgrade during peak business hours without adequate testing or a rollback plan represents a significant regulatory and ethical failure. This approach disregards the fundamental responsibility to ensure business continuity and could lead to a direct violation of SLAs, potentially incurring financial penalties and legal repercussions. It also demonstrates a lack of due diligence in risk assessment and mitigation. Performing the upgrade without any prior testing in a lab environment and immediately deploying to production is reckless. This ignores established industry best practices for system deployment and carries an unacceptably high risk of unforeseen issues causing widespread outages. Ethically, it fails to uphold the duty of care to the organization and its users. Focusing solely on the technical aspects of the upgrade and neglecting stakeholder communication and impact assessment is also professionally unsound. While technical proficiency is crucial, ignoring the business implications and the needs of users and management can lead to project failure and dissatisfaction. This approach fails to meet the broader ethical obligation of IT professionals to align technology solutions with business objectives and to manage change responsibly. Professional reasoning. Professionals facing such a scenario should adopt a structured, risk-based approach. This involves 1. Comprehensive requirements gathering, understanding the business needs and technical requirements for the storage network upgrade. 2. Risk assessment and mitigation planning, identifying potential risks e.g., performance degradation, connectivity issues, data corruption, and developing strategies to mitigate them, including rollback procedures. 3. Phased deployment strategy, planning for a gradual rollout starting with lab testing, followed by a pilot on non-production or less critical systems, before proceeding to the full production environment. 4. Stakeholder communication, establishing clear and consistent communication channels with all affected parties, providing regular updates on progress, potential impacts, and mitigation efforts. 5. Change management, adhering to formal change management processes to ensure proper approvals, documentation, and scheduling of the upgrade. 6. Post-implementation review, conducting a thorough review after the upgrade to assess its success, identify lessons learned, and document any deviations from the plan. Question 17. The control framework reveals a senior manager requesting direct access to a database containing sensitive customer billing information, stating it's for a quick, informal review to identify potential cost-saving opportunities, bypassing the standard data access request and approval process. The IT professional responsible for this database is aware that this type of access is not logged by the standard auditing tools and could potentially violate data privacy policies. Option A. Provide the senior manager with a read-only copy of the entire database, explaining that this is the closest they can get to direct access without violating policy. Option B. Inform the senior manager that direct access is not permitted due to policy and regulatory compliance requirements, and offer to retrieve specific, anonymized data points that align with their stated objective, following the established data request procedure. Option C. Grant the senior manager direct access to the database as requested, assuming their authority and intent are benign, to avoid potential repercussions for delaying their request. Option D. Immediately deny the request and report the senior manager to their direct supervisor and the compliance department for attempting to circumvent established security protocols. The correct answer is B. Inform the senior manager that direct access is not permitted due to policy and regulatory compliance requirements, and offer to retrieve specific, anonymized data points that align with their stated objective, following the established data request procedure. Explanation. The control framework reveals a potential conflict of interest and a breach of data privacy principles within a data center environment. The scenario is professionally challenging because it requires an IT professional to balance their responsibility to their employer with their ethical obligations regarding data security and privacy, especially when faced with pressure from a superior. The core of the challenge lies in recognizing that even seemingly innocuous requests can have significant privacy implications, and that adherence to established protocols and regulations is paramount. The correct approach represents best professional practice, because it prioritizes adherence to the established data governance policies and regulatory compliance, specifically those related to data privacy and security as mandated by U.S. federal regulations, e.g., HIPAA for healthcare data, or NIST frameworks for general data protection. By escalating the request through the proper channels and seeking clarification on the legitimacy and security implications of accessing sensitive customer data, the professional upholds their duty to protect confidential information and ensures that any data access is authorized and compliant. This aligns with the ethical principle of acting with integrity and competence, and the regulatory requirement to safeguard sensitive data. An incorrect approach that involves directly providing the requested access without verification or escalation would represent a significant regulatory and ethical failure. This would violate data privacy laws by potentially exposing sensitive customer information without proper authorization or a legitimate business need, leading to severe legal repercussions, fines, and reputational damage for both the individual and the organization. It also demonstrates a lack of professional integrity and a failure to uphold the duty of care owed to customers. Another incorrect approach, such as ignoring the request or attempting to circumvent the superior's directive without proper documentation or escalation, is also professionally unacceptable. While it might seem like a way to avoid direct conflict, it fails to address the underlying issue and could be interpreted as insubordination or an unwillingness to collaborate. More importantly, it does not ensure that the data remains protected or that the request is handled appropriately according to policy. This approach lacks the proactive and transparent communication essential for ethical decision-making. The professional decision-making process for similar situations should involve a clear understanding of organizational policies, relevant regulations, and ethical guidelines. When faced with a request that raises concerns, the professional should 1. Pause and assess the request against established policies and regulations. 2. Seek clarification from the requester if the purpose or implications are unclear. 3. If concerns persist, escalate the request through the appropriate channels, e.g., Management Legal Compliance Department for review and guidance. 4. Document all communications and decisions. 5. Prioritize data security and privacy above all else, even when faced with pressure. Question 18. Process analysis reveals their new Cisco Unified Computing System, UCS, implementation is scheduled for a critical production environment. The project team is evaluating different deployment strategies to minimize disruption and ensure successful integration. Which of the following approaches best aligns with industry best practices for implementing complex data center unified computing solutions? Option A. Deploy components in a phased manner, with thorough testing and validation at each stage, before proceeding to the next, ensuring integration and functionality. Option B. Implement all components and configurations in a single, large-scale deployment event to expedite the go-live date. Option C. Implement individual components independently without a comprehensive integration plan, focusing solely on getting each piece operational. Option D. Prioritize rapid deployment by skipping detailed validation steps and relying primarily on vendor default settings for all components. Correct answer is B. Implement all components and configurations in a single, large-scale deployment event to expedite the go-live date. Explanation. Scenario analysis. Implementing Cisco Data Center Unified Computing Solutions involves managing complex, interconnected systems. A key challenge in this domain is ensuring that the chosen implementation approach aligns with established best practices for performance, scalability, and manageability, while also adhering to any relevant regulatory or compliance frameworks that might govern data center operations. The scenario presents a situation where a new implementation needs to be deployed, and the decision maker must evaluate different strategic approaches. The professional challenge lies in balancing immediate deployment needs with long-term operational efficiency and risk mitigation, all within the context of the specific technologies and potential operational environments dictated by the 300-175 exam scope. Correct approach analysis. The correct approach prioritizes a phased, iterative deployment strategy that includes thorough validation at each stage. This aligns with Cisco's recommended methodologies for implementing complex solutions, emphasizing a crawl, walk, run philosophy. This approach allows for early detection of issues, minimizes the impact of potential failures, and ensures that each component is functioning as expected before proceeding to the next. From a best practice perspective, this reduces risk, improves the likelihood of a successful deployment, and facilitates easier troubleshooting. It also allows for continuous learning and adaptation throughout the implementation process, which is crucial for complex unified computing environments. This methodical approach is inherently more robust and less prone to cascading failures than a big bang deployment. Incorrect approaches analysis. One incorrect approach involves a big bang deployment where all components are implemented simultaneously without intermediate validation. This is professionally unacceptable because it significantly increases the risk of widespread failure. If an issue arises, it becomes extremely difficult to isolate the root cause among numerous simultaneously introduced changes, leading to prolonged downtime and potential data loss. This approach disregards fundamental risk management principles and best practices for complex system deployments. Another incorrect approach is to bypass comprehensive testing and validation in favor of rapid deployment, relying solely on vendor default configurations. This is professionally unsound, as it ignores the critical need to tailor the solution to the specific environment and requirements. Vendor defaults are generic and may not be optimized for performance, security, or compatibility with existing infrastructure, leading to suboptimal performance and potential security vulnerabilities. This approach fails to meet the professional obligation to ensure a robust and secure implementation. A third incorrect approach is to implement components in isolation without considering their integration within the unified computing fabric. This leads to a fragmented and inefficient system. Best practices dictate a holistic view of the data center infrastructure, where each component's role and interaction with others are understood and managed. Failing to integrate components properly results in operational silos, increased complexity in management, and a failure to realize the full benefits of unified computing. Professional reasoning. Professionals tasked with implementing Cisco data center unified computing solutions should adopt a structured, risk-aware methodology. This involves 1. Thorough planning, understanding project requirements, scope, and potential constraints. 2. Phased implementation, breaking down the deployment into manageable stages with clear objectives and validation points. 3. Rigorous testing and validation, ensuring each stage meets predefined success criteria before proceeding. 4. Integration focus, verifying that all components work seamlessly together as a unified system. 5. Documentation and knowledge transfer, maintaining detailed records and ensuring team understanding. This systematic approach, grounded in risk mitigation and best practices, ensures a higher probability of success, minimizes disruption, and leads to a more stable and efficient data center environment. Question 19. Research into a new data center storage solution has led to a short list of 2 vendors. One vendor, aware of the upcoming evaluation, offers the IT team a pre-release training session on their upcoming product features, which they claim will be highly beneficial for understanding the full capabilities of their offering. This training is not available to other vendors' teams at this stage, and is being offered exclusively to your team before the formal evaluation period begins. What is the most ethically sound and professionally responsible approach for the IT team to take in this situation? Option A. Inform the vendor that the training offer is inappropriate and suggest they provide the same opportunity to all shortlisted vendors simultaneously. Option B. Politely decline the offer, stating that the evaluation will proceed based on publicly available information and standard vendor demonstrations to maintain objectivity. Option C. Accept the pre-release training session, as it could provide valuable insights into the vendor's technology, and then disclose the participation to management. Option D. Accept the pre-release training session, as it is a valuable learning opportunity, and use the knowledge gained to inform the evaluation without disclosing the source of the information. Correct answer is B. Politely decline the offer, stating that the evaluation will proceed based on publicly available information and standard vendor demonstrations, to maintain objectivity. Explanation. This scenario presents a professional challenge because it involves a conflict between a vendor's desire to influence a purchasing decision and the IT professional's duty to act in the best interest of their organization. The core of the challenge lies in maintaining objectivity and integrity when faced with potential personal gain or preferential treatment. The 300-175 Implementing Cisco Data Center Unified Computing Exam focuses on the technical aspects of implementing Cisco solutions, but ethical considerations are implicitly part of professional conduct in any IT role, especially when dealing with procurement and vendor relationships. The correct approach represents best professional practice because it prioritizes the organization's needs and ensures a fair and transparent procurement process. By adhering to company policy and seeking objective evaluation criteria, the IT professional upholds their fiduciary responsibility to their employer. This aligns with general ethical principles in business and IT, which emphasize honesty, integrity, and avoiding conflicts of interest. While the exam itself may not directly test ethical frameworks, the professional application of the technologies covered requires such principles. An incorrect approach that involves accepting the vendor's offer of a pre-release training session, even if framed as beneficial, represents a regulatory and ethical failure. This could be construed as accepting a gift or preferential treatment that could bias the evaluation of the vendor's solution. It creates an appearance of impropriety and a potential conflict of interest, undermining the integrity of the procurement process. Such actions could violate internal company policies on vendor interactions and gifts, and in a broader sense, breach the ethical obligation to act impartially. Another incorrect approach, which is to immediately dismiss the vendor's offer without considering its potential value or exploring it within established company guidelines, might be overly cautious and could lead to missing out on valuable information. While avoiding bias is crucial, a complete refusal without due diligence might not be the most effective way to serve the organization's interests if the training genuinely offers objective technical insights. However, the primary ethical failure here is less about outright corruption and more about a potential lack of thoroughness in evaluating all legitimate avenues for acquiring knowledge, provided it's done transparently and without compromising objectivity. A third incorrect approach, which is to accept the offer and then disclose it to management, is still problematic. While disclosure is a step towards transparency, accepting the offer in the first place, especially a pre-release training, still creates the appearance of impropriety and potential bias. The ethical failure lies in putting oneself in a position where such a disclosure is necessary, rather than proactively avoiding situations that could lead to conflicts of interest. The best practice is to prevent the conflict from arising in the first place. The professional decision-making process for similar situations should involve a clear understanding of company policies regarding vendor interactions, gifts, and procurement. When faced with such a scenario, the IT professional should 1. Identify the potential conflict of interest. 2. Consult company policy for guidance. 3. Prioritize objective evaluation criteria. 4. Seek guidance from their manager or procurement department if unsure. 5. Maintain a clear separation between personal benefit and professional duty. The goal is always to ensure that decisions are made based on the best interests of the organization, free from undue influence or bias. Question 20. Strategic planning requires a proactive approach to integrating new unified computing technologies within a data center environment. A key stakeholder, focused on accelerating time to market for a new service, is advocating for the immediate deployment of a novel storage virtualization solution. However, concerns have been raised internally regarding its potential impact on existing data residency and access control policies, which are governed by specific industry regulations. Which of the following actions best demonstrates professional responsibility and adherence to regulatory frameworks in this scenario? Option A. Proceed with the immediate deployment of the storage virtualization solution to meet the stakeholders' urgent business needs, with a plan to address any potential compliance issues retrospectively. Option B. Conduct a comprehensive review of the proposed storage virtualization solution against all applicable data residency and access control regulations, engaging with legal and compliance teams to validate its adherence before proceeding with any deployment. Option C. Reject the proposed storage virtualization solution outright due to the potential compliance concerns, prioritizing the avoidance of any regulatory risk, even if it hinders business objectives. Option D. Implement the storage virtualization solution with minimal configuration changes, assuming it will align with existing policies, and only investigate compliance if a specific issue is flagged by an auditor. The correct answer is B. Conduct a comprehensive review of the proposed storage virtualization solution against all applicable data residency and access control regulations, engaging with legal and compliance teams to validate its adherence before proceeding with any deployment. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid technological adoption and the need for robust, compliant data center infrastructure. The Cisco 300-175 exam focuses on implementing unified computing, which involves complex integration of compute, storage, and networking. When stakeholders, particularly those focused on immediate business needs, push for solutions that might bypass established security and compliance protocols, a data center engineer must navigate these pressures while upholding regulatory adherence. The challenge lies in balancing innovation with risk management, ensuring that any implemented solution meets not only functional requirements, but also the stringent legal and industry standards relevant to data center operations. The correct approach represents best professional practice because it prioritizes a thorough assessment of the proposed solution against existing regulatory frameworks and internal policies. This proactive due diligence ensures that the implementation aligns with compliance mandates, such as data privacy regulations, e.g., HIPAA if dealing with healthcare data, or GDPR if applicable to data processing and industry-specific security standards. By engaging with compliance and security teams early, the engineer demonstrates a commitment to responsible technology deployment, mitigating potential legal liabilities, reputational damage, and operational disruptions that could arise from non-compliance. This aligns with the ethical obligation to protect sensitive data and maintain the integrity of the IT infrastructure. An incorrect approach that involves immediate implementation without proper validation would represent a significant regulatory and ethical failure. This could lead to violations of data protection laws, resulting in substantial fines and legal repercussions. Furthermore, it breaches the ethical duty to safeguard organizational assets and sensitive information. Another incorrect approach, such as delaying the integration indefinitely due to minor concerns, fails to meet business objectives and could be seen as a dereliction of duty to support organizational growth, potentially leading to missed market opportunities and competitive disadvantage. This also overlooks the professional responsibility to find compliant solutions, not simply to avoid change. A third incorrect approach, focusing solely on cost reduction without considering compliance implications, is ethically unsound as it prioritizes financial gain over legal obligations and security, creating a high-risk environment. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes identifying all relevant regulatory requirements, evaluating the potential impact of the proposed technology on compliance, consulting with legal and compliance departments, and documenting all decisions and their justifications. Professionals should always advocate for solutions that are both innovative and compliant, seeking to find ways to achieve business goals within the established legal and ethical boundaries.